Hi guys, welcome to another Under the Hood of. Today we'll be looking at NPM. NPM is the official package manager for the Node.js ecosystem. It was first released, since Node was first released, it's come with NPM built in. The initial release date for NPM was 12th of January in 2010. Since then it's grown into the world's largest software registry. I would expect most engineers in the JS ecosystem to know all about either NPM or Yarn, as they're critical to most local CI and CD flows. However, in the overview section, I'm going to cover the core functionality, as this is what we'll be focusing on building later. This talk will be broken down into two parts. Part A will be an overview. We'll look at the CLI, the registry, the website, and modules versus packages. And then part B will be building our own Node.js package manager, including a registry, a CLI, and a website. And then finally, what have we missed? What ours does not do, which the real one does. So, we start with part A, our overview. So, the CLI is open source code available on GitHub. It's currently on version 7 and has had over 700 contributors. The CLI commands are Node.js scripts and require the format npm command. You can actually point the CLI to any registry. As you can see here, npm add user, give any registry there. A couple of the commands, so npm init will create a new package, set up a new package, creates the package JSON, among other things. npm install, the code is located in that install file there. It uses npm registry fetch, which you can see there. It generates node modules, it downloads the dependencies defined in the package JSON. We'll come to the module resolution next. It downloads, it generates a log file, we'll see log file next as well, and it utilizes a cache, and we'll look at the cache next as well. So, a bit more on the install. So the log file, it generates a package log.json describing the dependency tree that was installed. This is for deterministic installs, so for subsequent installs. If the lock exists, the install is driven by that. The log file stores an integrity hash for each dependency. This hash, or checksum, is of the package tarball uploaded to the registry. It can be SHA-1, which is the old NPM, or SHA-512, which is the newer NPM. It's akin to a sub-resource integrity check in HTML browsers. Point on the module resolution. So NPM installs per package, and sequentially, i.e. it moves on once that package is installed. This means it can be quite slow to finish. Currently, it installs all of the nested dependencies as efficiently or flat as possible. If a version is the first for a dependency, it is top level. If it's not the first version, then it's stored with the parent who requires it. So you can see the diagram explaining more there. The old package resolution, which is pre-NPM 5, was done on disk by Node.js, Node modules. This was much slower and is not used anymore. So, final point on NPM install, on the cache. It stores the HTTP request and the response data and other package-related data. It uses a library called Pacote. The library is responsible for package fetching. All the data passed through the cache is verified for the integrity on insertion and extraction, and cache corruption will usually trigger a refetch, so clearing the cache should only be necessary for reclaiming disk space. That should be the only time you need to clear the cache. A couple of other commands. We've got npm version, which bumps the local version, updates the package JSON and the package lock, also creates a version commit and a tag for Git. And there's npm pack, which creates a tarball, which is the zip of the package. It's under like package.tar.json, .gz. And there's an example screenshot there on the right of it being produced. And then npm publish, code is located in this publish.js file. It runs npm pack as part of it. It sends the tarball to the registry. And publishing a package consists of at least one step, which is this HTTP put with metadata payload and a tarball. So you can see in the logs it prints npm HTTP fetch put and the response, 200. So the registry, it's a large public database of JavaScript packages and the meta information surrounding it. It's version, so it's like Git. It uses Apache's NoSQL database CouchDB to manage publicly available data. It offers good storage performance and replication. It has a database for users and one for registry, and the latter holds the packages. On the tarballs, there's a link to more of it there, but it uses CouchDB's attachments for package tarballs It's really easy to upload or download an attachment from CouchDB, simpler than most of the other NoSQL alternatives. And there's an API. So Couch naturally exposes a HTTP endpoint, which means it has an API built into it by default. For auth, there is a /_session endpoint there, which is to create a new cookie-based session, or it accepts an authentication header for basic auth, both natively. You can use design document rewrites, and we'll get to that in a second. You can build redirects to different parts of the database. And then querying. So CouchDB is very dynamic in that it allows you to create a kind of schema called a design document for a given section. This can include JavaScript functions. It can store and run JS code internally, which is really cool. Which you can get to execute at given events. So for example, if you're updating a list of functions, will run when a document is updated. It also has views, which are functions that take the document data and produce searchable lists of information based on the document's contents. There are other types of mechanisms, more details in that link. A couple of other links. We've got the CouchDB tables and the API for registry details. The CouchDB views. An example Docker image for their DB setup is NPM Docker CouchDB. It details how to update a local NPM client to use a local DB registry. And then finally, some apps use this very popular lightweight proxy app, the -io, for many reasons, one of which is the independent caching in case NPM is down. So, the website, found at npsjs.org, a domain which was first registered in March 2010, so it's 11 years old. It's built using Webpack, React, and Lodash. Its assets are served via the CDN Cloudflare. Any payments are processed via Stripe. It connects and reads data from the registry CouchDB instance. Packages are located at npm.js/packages/package. The README Markdown file is loaded as the landing page content with Markdown rendered as HTML, which is pretty cool. NPM also shows a load of other information, such as weekly download number, latest version, unpackaged size, and GitHub location. See the image on the top right, which you'll all be very familiar with. Finally, a note on modules versus packages. A module is a file or directory that can be loaded by Node.js, located inside Node modules. CLI packages are not modules. They cannot be loaded by Node.js until they're unzipped into a folder first. Two versions of the same module can exist, so for instance, version 1 and version 1.01, and they will not conflict. Generally, NPM packages are modules, and they're loaded via require or import. So, now on to part B. We're going to be building our own Node.js package manager. So, we'll be building an app which consists of all three aspects of NPM. The aim is to get a basic proof of concept which will work for all three. We're going to be using a registry, CLI, and a website. So we're going to be using an example lib, which is a small package which returns some text, and example app, which is a small express server using the previous package. And we can use those to test it works. We're going to wrap all of the above into a single mono repository with multiple packages. So, the registry. For this, we're going to use the default CouchDB Docker image. It includes a basic unauthenticated CouchDB instance. I've decided to use Docker Compose to set up our apps. So you can see on the left, our Docker Compose YAML starts like you see here. It doesn't need a volume mounted or anything at this point. And then on the right, we're going to be making use of a makefile to assist in running it. So we're going to start by building and creating the registry, the registry database. And then later I added a stop and reset so we can kill the Docker application and reset the database quickly. And then opening the database, the browser confirms the database and the CouchDB instance exists, and you can see that image at the very bottom. Onto the CLI, located in our monorepo in packages CLI. We're only going to be creating two commands for the POC, so install and publish. So the package JSON will look like this on the left. Using binaries means that inside the package CLI folder, we can run a global install. And from any directory in the terminal, we can run the commands on the left. So we'd run npm install global, and then we've got these commands that we could run, rnpm publish and rnpm install. I've chosen to split these into a single script and use arguments, like the real npm, but it did not, I could have chosen to do it like the real one does, like pressing the arguments, could have used something like yargs to do it, but it didn't seem worth it for this proof of concept. So, the install script. Located at the packages CLI scripts install. It is 4 steps. Step 1 you can see on the right hand side. Grab the package name and the rdeps object from the current working directory package.json. Step 2, just below that, iterate over each item in rdeps. The version is ignored for our proof of concept. Then we make a fetch request to the CloudDB tarball attachment. It would be like the /registry /repo name /repo name.tar.gzip, and then write the file to a local temp tar.gzip for processing. Step 3, if we now go on the left, we extract the temp.tar.gzip contents from the tar library into the current working directory modules, the current working directory's node modules /the repo name. And then step 4, finally, we delete the temp tar.gzip. Looking at the publish script now, located at packages CLI script publish. So it is 4 steps as well. So we're going to start on the right by the run. So from the current working directory, grab the package.json file name field, and then 1.2, the readme.md contents. Step 2 now, onto the package repo function, create a tarball of the current working directory. Now step 3, which is on the left, for the send package, we're going to send the package tarball as an attachment and the readme contents as plain text to our CouchDB instance. The document name is the package name. And then step 4, finally, which is at the bottom on the right, we're just going to delete the local tarball file. So now onto the website. Located under packages/website, we're going to be using Docker to create a basic Node.js application, and the Docker file looks like this. We're pulling from the Node Alpine image, creating the app directory, install the dependencies, bundle the app source, and then run start dev. So the website continued. So the website details are located in the package website source server.js. So let's go through the steps. So step 1, inside the just inside the request. So for a request to the packages/package name URL, so now on the right here, we're going to query the CouchDB instance for the package name. That's on the left, step 1. And then step 2, back on the right, using the showdown library, render the README markdown as HTML. If no package is found, a nice message is printed. So you can see there on the right, no package found. Lastly, we're going to add the website to our Docker Compose, so we can run it with the registry database. So the Docker Compose now looks like this. So we've got our web, we've got 2 services, we've got the website and the CouchDB database. So we now have 3 of the core 3 jobs carried out by NPM. So we need to test it works by using an example application and an example library. So example lib, located under packages example lib, will just return a string. So you can see it's here's the JSON, here's the package JSON there, and the index file there. It's just going to return this example lib data. Now onto the second part of testing the app. We've got the example app, which will print information from the real library, from a real library using Express and our external library. So the packages example app package.json looks like this on the left. As mentioned, the version is ignored for our proof of concept, so I've just put null there. The packages example app source index is below. You can see I've just imported Express and our example app lib, just printing the statement and also just printing some code from the Express function from the URL encoded function, just one picked at random. So lastly, test it works, we're going to update the rest of our makefile to also remove the package installed and uninstall the global binary commands. So the final makefile looks like this. You can see inside the reset, we've included the global installs. So now we will run our example. The first half of the steps are here. So we've got our setup commands. So we run makeup, make reset, and then makeup. So we're going to check the website for the package. We could open that URL there. We would see the package does not exist. We get a nice message. we then run the script to set up the database in the CLI, so make DB. We can then change directory into the CLI, install the script globally. Now we're going to publish the package, then check the website. So we're going to change directory into the example lib, run our npm publish script, which is going to publish the example lib to our registry. So continuing from previously, so we can now open the example lib.tar.gzip location of the package registry, and we can now see that the package readme is there. So you can see that on the website. Now we want to make use of this package. Now we've got the website connected to the registry, and the registry with a zip with a package inside that we've published from our script. So those are the first kind of 12 commands. Now we want to use this package. So we're going to change directory into the example app. I'm going to run npm start, and we'd see that we're getting a missing package error, which is exactly what we expect. Now we run our global install binary command, and it will install the package from the package JSON from the rdeps list. And then we run npm start, and the package is found. And now you can see it works. So that's it. Our mini npm works. Good stuff. So what have we missed? As mentioned, there is functionality to each of the 3 core concepts, elements to npm, which we have omitted from app. Just some. There are many, I know. So CLI, various commands, including init and pack, the ability to download a package via an argument, creating a lock file, which computes versions and dependency info, caching and request response data, flags, so if you just want to include install a certain part of the package JSON, dependency module resolution, which NPM has a lot of logic for this, which we had touched on previously. The registry, so there's no authentication, so we could add some better authentication on the CouchDB instance. Having a SHA-512 some hash of the actual tarball content itself for this sub-resource integrity check. We don't do any checks. An install counter, a semvar package versions, and then finally the website, show an install counter, show versions, and an integrity hash, and a decent UI. It was horrendous. It was just a completely white screen. So that's it. Thanks so much for watching. I learned a huge amount about NPM from this research, and I hope it was useful for you, even as a refresher. You can find the repository for all this code here, and check my site for more under the hood ofs. Thanks very much. Take care.